Today in this video we are going to study the unit step function. The definition of the unit step function and the very simple problems associated with unit step function. Unit step function is also called Heaviside function, which is named after Oliver Heaviside. So here we have a definition. The unit step function is denoted by u of t minus a, or Heaviside function h of t minus a, and it is defined as follows. It is defined as u of t minus a is equals to 0 if t is less than or equals to a, and u of t minus a is equals to 1 if t is greater than a, where a is a positive constant. We have few properties associated with the unit step function. The first property is Laplace transform of u of t minus a is equals to e power of minus as by s, and the second property is given by Laplace transform of f of t minus a into u of t minus a is equals to e power of minus as into f bar of s, where f bar of s is equals to L of f of t. And we have a third property stating that if f of t is equals to f1 of t for t is less than or equals to a, and f2 of t for t is greater than a. And if we have a function of this type, we have to put our f of t in this form, that is f of t is equals to f1 of t plus f2 of t minus f1 of t multiplied with u of t minus a. And we have a last property, that is the fourth property. If f of t is equals to f1 of t for t is less than or equals to a, and f of t will be equals to f2 of t if t varies between a and b, that is a less than t less than or equals to b, and f of t is equals to f of 3 if t is greater than b. So if we have a function of this kind, we have to rewrite our f of t in this form, that is f of t is equals to f1 of t plus f2 of t minus f1 of t into u of t minus a plus f3 of t minus f2 of t into u of t minus b. So now let us solve a problem by using these properties. We have a first problem. We have to find the Laplace transform of the following function. The given function is e power of t minus 1 plus sine of t minus 1 into u of t minus 1. So first we have to observe that the given function is in which form. So if we see this particular function, we can clearly make out that the given function is in the form of a second property. So let us write the property 2 once again, that is the second property. Property 2, or second property is Laplace transform of f of t minus a into u of t minus a is equals to e power of minus as into f bar of s. So here you see this function, we have to assume it as our u of t minus a, and a function which is multiplied with u of t minus a will be your f of t minus a. So this way we have to identify which property we have to make use of here. So this is our u of t minus a, and let us assume the function which is multiplied with u of t minus a will be our f of t minus a. So if we have a function of this form, we have to apply this property, that is e power of minus as into f bar of s. So to apply this property, so we should know the value of a as well as our f bar of s. So if I compare the given function with this, I have u of t minus as u of t minus 1. So in this I can clearly make out that my a is equals to 1. And what is our f bar of s? We have to find our f bar of s. And we already know that f bar of s can also be written as Laplace transform of f of t. So we are already familiar with this property. So if I want to find my f bar of s, I have to find my Laplace transform of f of t. But what is our f of t? what is our f of t. Okay, so but to find our f of t, so we have to make use of the given data in the problem. Okay, the given data in the problem is our f of t minus a, that is f of t minus 1. By using this function we have to find our f of t. So now to find f of t, let us consider f of t minus a, that is f of t minus 1 is equals to e power of t minus 1 plus sine of t minus 1. So this is our f of t minus 1 now. So since I need only f of t, so I have to replace all my t by t plus 1 to get my f of t. If I replace all t by t plus 1, I'll get my f of t over here. Okay, so in this function replace t by t plus 1, so that I'll be having f of t plus 1 minus 1, which is equals to e power of t plus 1 minus 1 plus sine of t plus 1 minus 1. Okay, and here plus 1 minus 1 will get cancelled, here also plus 1 and minus 1 will get cancelled, here also plus 1 and minus 1 will get cancelled, and we will be left out with f of t is equals to e power of t plus sine t. So this is our f of t. So once you know your f of t, you can find your f bar of s. Okay, so therefore f bar of s is equals to Laplace transform of f of t. Let us substitute f of t over here, that is f of t is equals to e power of t plus sine t, e power of t plus sine t, and we already know the formula of Laplace transform of e power of at is given by 1 divided by s minus a. This is the general formula, and Laplace transform of sine at is given by Laplace transform of sine at is given by a divided by s square plus a square. Okay, so now we have to make use of these formulas to find Laplace transform of e power of t and Laplace transform of sine t. Okay, so now let us split this function. We have to find Laplace transform of e power of t separately and Laplace transform of sine t. So Laplace transform of e power of t. So here if I compare this e power of t with this, I can clearly make out that my a is equals to 1 over here. So if I substitute my a as 1 over here, so I'll get my answer as 1 by s minus 1 plus Laplace transform of sine at. You can see this is of the form sine at, so where my a will be equals to 1. So that let us put a is equals to 1 in this formula, so that we will be having 1 divided by s square plus 1 square. So this is my f bar of s. So now I know what is my f bar of s. Okay, so after finding your f bar of s, substitute your f bar of s in the property 2, that is in the second property. So let me name this as some equation number 1. So therefore equation number 1 gives Laplace transform of, substitute your f of t minus a, that is e power of t minus 1 plus sine of t minus 1, and u of t minus 1 multiplied with u of t minus 1 is equals to e power of minus as. What is your a? Your a is equals to 1. So I'll get e power of minus s into f bar of s. Substitute your f bar of s, that is 1 divided by s minus 1 plus 1 divided by s square plus 1 square value will be equals to 1. So this is the required Laplace transform of the given function by using unit step function. This is the method you have to follow for all the problem to find the Laplace transforms by using unit step function properties.